Today we're going to use the power rule in finding the derivatives of some functions in my example. So the first one that we're going to be working on will be y equals x cubed all over 3 plus x squared all over 2 plus x. So the first step that you are going to be doing is to change the function into this. And by doing so, the power rule will be a lot easier to use because we're just going to multiply 1/3 with the derivative of x cubed. So y prime is equal to the derivative of 1/3 x cubed plus, we can also write it as 1/2 ddx of x squared plus ddx of x. So we know that every constant, we can just ignore it and take the derivative of x cubed. So we'll have 1/3 times the derivative of x cubed, which is 3 times x squared, plus 1/2 times the derivative of x squared, which is 2 times x, plus the derivative of x, which is simply 1. So now that we have our y prime, all we need to do is to simplify our answer into, because we can cancel 1/3 and 3, so 1/3 times 3 is simply 1, so we'll end up with x squared plus, cancel this, plus 1. So this is the derivative function of x cubed all over 3 plus x squared all over 2 plus x, which can also be rewritten as dy dx. So this is another notation of y prime. Now let's go ahead and move on to example number 2. In example number 2, we are going to be using the power rule once again, but before we can use that, let's change our square roots or the cube roots into fractional exponent. So we'll have g of x, so instead of using g of x at this form, we can use 5x to the negative 3 all over 5 minus 7 e to the x minus 4x to the 1/3. So finding the derivative would be g prime of x is equal to 5 times the derivative of x to the negative 3 all over 5. So it means that I'm just ignoring my coefficient, which is 5, but focusing on the derivative of x raised to the negative 3 over 5 minus 7 times the derivative of e to the x minus 4 times the derivative of x to the 1/3. So let's go ahead and find the derivative of the first term, which is simply g prime of x is equal to 5 times the derivative of x to the negative 3 over 5 would simply be negative 3 all over 5 x to the, so let's subtract 1 from negative 3 over 5, so we have negative 3 over 5 minus 5 over 5, which is also 1, which will give us negative 8 all over 5. So this is negative 8 all over 5. So that's the derivative of our first term. Now let's go ahead and take the derivative of the second term. So the derivative, so let's copy the coefficient first, which is 7, multiplied by the derivative of e to the x. Now, the derivative rule for ddx for e to the u, as we know, is e to the u times du over dx. And in this case, the derivative of x, so if we have e to the x times the derivative of the exponent, which is x, is simply 1. So the derivative of e to the x is simply e to the x. So with that, we know that we can use this as our derivative function for e to the x. So we are simply going to copy e to the x over here. Minus 4 times the derivative of x raised to 1/3, which is going to be 1 over 3 times x to the 1/3 minus 1. So let's use this space over here to subtract 1 over 3 from 3 all over 3, which gives us negative 2 all over 3. So this is negative 2 all over 3. So we can say that the derivative function of x or g of x will simply be, so by simplifying this fraction right here, we can cancel 5 and 5 and we'll end up with negative 3 x to the negative 8 over 5 minus 7 e to the x minus 4 times 1 over 3 is 4 over 3 x to the negative 2 all over 3. So this is our derivative function for g of x. However, if you want to further simplify this by changing all your negative or fractional exponent into radical, we can rewrite this as g prime of x is equal to, so this can be changed into negative 3 all over x fifth root of x to the 8th. This one we don't need to change it, minus this one can be changed into 4 over 3 cube root of x squared. So this is another version of our derivative by simplifying it using algebra. So that's problem number 2. Now let's have the derivative of our third example, which is x squared plus 3 all over x. X squared plus 3 all over x. So once again, we're still using the power rule, and to use the power rule, we're going to modify our fraction into power rule by doing this. So instead of using f of x with this fraction, I can change this and modify this by multiplying this by x to the negative 1, because x as a denominator can be changed into x to the negative 1 using the law of exponents. So by doing so, I can now distribute my x to the negative 1 to my function x squared plus 3. So we know that we're simply adding fraction, exponents, if we're multiplying terms like this. So f of x, notice that it's still f of x because we're not doing any calculus work yet. So we're just simplifying this plus 3x to the negative 1. And we know that 2 minus 1 is negative 1. So f of x is x to the 1 plus 3x to the negative 1. So from x squared plus 3 all over x, now I modified it into x to the negative 1 plus 3x to the negative 1, so I can easily use the power rule in deriving my f of x. So f of x is simply the derivative of x is 1, plus the derivative of 3 times x to the negative 1 is simply 3 times negative 1 x to the negative 2. So f prime of x is simply 1 minus 3 x to the negative 2. So this is my derivative. And once again, if you have a negative exponent, you can change it into positive exponent by modifying your answer into this. 1 minus 3 all over the square root of x. So this is another version of your answer. And that's example number 3. Now let's answer example number 4. So just like what we did on example number 3, we're going to modify the function so we can use the power rule to this example, and we'll end up with u of x equal to 3x squared plus 2x raised to 1/2 multiplied to x to the negative 1. And by distributing the term right here, we know that we can change our u of x into 3x 2 minus 1 plus 2x 1/2 minus 1. So our new function will be 3x to the negative 2 minus 1 is simply 1 plus 1/2 minus 1. So if I have 1/2 subtracted to 2 over 2, which is also 1, is going to give me negative 1/2. So we'll have 2x to the negative 1/2. Notice that it's still u of x because we haven't used the power rule yet. So to use the power rule, now we'll have u prime of x. equal to 3 ddx of x plus 2 times ddx of x to the negative 1/2. So I just isolated my constant so you can see what I'm going to do with this function right here. So u prime of x is equal to, derivative of x is simply 1, so it's just 3 plus derivative of x to the negative 1/2 is 2 times negative 1/2 times x to the negative 1/2 minus 1. And we know that negative 1/2 minus 2 all over 2 is simply negative 3 all over 2. So our final answer for u prime of x is 3, cancel this, minus x, and this is our exponent right now, negative 3 all over 2. That's u prime of x, which is, or which can also be simplified into 3 minus 1 over square root of x cubed. Another version of our derivative. And that is how we use the power rule in solving functions like the four examples that I have shown you.